tonight is Logan Wagner, and he is an architect, and he's also a PhD, and which is pretty cool that he's both of those things. He graciously agreed to present tonight, and you live in Austin, right?
Yes.
Yes, so he drove here from Austin to be able to give this presentation to us, and so I'm very, very happy that we have such a big crowd here to see him and greet him for that. And he's an architect that's actually worked with Earthen Materials, so we get to get that perspective from him. And your company is called Alarife? Alarife, yes. And you're from Mexico?
I grew up in Mexico.
He grew up in Mexico. So we do this series every month. We've done it for, I think, like 18 consecutive months now, something like that. And we've had a speaker for each one of those months, except for 1 month. It was around the holidays, and we decided to show a film instead. And we even had a full house for that evening. So we've had a great turnout. Last month we were in Austin. We had Christoph Irwin, who is a mechanical engineer, well, electrical engineer by trade, but in his business is mechanical engineering. He's strictly residential, and he has a great interest in sustainable construction and earthen materials too, so he was a great speaker that we had. And we actually have a lot of members in Austin, so we actually had that board meeting and presentation in Austin last month. And we do hope in the future to get a few more Austin meetings on the calendar. And Christoph Irwin is finishing building a new office, and so we're hoping to work out something with him that we could actually meet at his space when that's completed. So that'll be cool, so stay tuned for that. So just check your emails and check Facebook and that kind of thing. Our website is easier to update now, so we will be posting these more regularly. That's our intent. With the information, so just make sure you stay tuned to where the meetings are. Through the rest of the year, they're going to be here, of course, at Southwest School of Art. And I think that's pretty much it. Anything else? Okay, well, Logan, thank you so much.
Okay, thank you. I want to thank ECI for inviting me to speak, and because I'm a member, I need to thank Michael and Beverly who first let me know about ECI, and I think it's a great organization, and we need to promote it because it's timely, very timely to have this organization. Okay, so what I wanted to present to you has to do with earthen construction and its embodied energy. Embodied energy is the amount of carbon footprint that it takes to build. From getting the raw materials, to producing the raw materials, to shipping it to the job site, machinery that's used at the job site, till the building is finished. Now, it's different to life cost analysis, because life cost analysis, what it does is take it from there and see how much the building is actually, how much energy it's using, what its carbon footprint, all the way till you demolish that building, what it takes. The advantage of working with earth is that when you demolish it, it just goes back to it. You know, we don't need a dump site for the material, it just goes back to the earth. Okay, so let's see if I can get this to work. Whoops. I can't. Oh, it's not that. It was going the right way. Okay, embodied energy. This is a graph that shows different building materials and how much embodied energy it takes to produce them. And they measure embodied energy in joules, Joules. And these are, some of the typical materials for we use in construction. there's a friend that I met not too long ago that has an energy consulting company in Austin. And to calculate the embodied energy is not an easy affair. You know, if you want to calculate exactly how much impact you're having, every single material in your buildings. And his company has access to this program that you just tell them what type of construction it is, and they'll tell you if it's, in general terms, if it's bad, if it's good, if it's more or less. And when he plugged in rammed earth, it just hit the ceiling. Said excellent. You know, so that's a real good thing for this system that we're using, rammed earth, and maybe leads and organizations like that can pay more attention to the impact of the building industry. There's between 40 and 60% of the carbon footprint is caused by the building industry. All of us that are involved in building industry, engineers, architects, builders, suppliers, transport people, all of that adds up. And probably of all the industries out there, we're the ones that cause the biggest impact. So what can we do to reduce that impact? And what I want to show you today is how ancient cultures, historic cultures, vernacular cultures have a real advantage on that. Because what they do, just like our ancestors when they first came here, they had to build with whatever was around them. It wasn't like, let's go to Home Depot and get concrete block. And so there's a lot of lessons that we can learn and we can apply to this 21st century and reduce our impact, those of us that are involved in the construction industry. So that's a table that shows you different levels of impact. Okay, one of the way you can get points in leads is to get your building materials within a certain area, a certain circumference, and they use, or at least they used to use, a 500-mile radius, and 500 miles is a long way, or 500-mile diameter. And there's all these different ecological systems where you can find all these different systems. Now the fallacy of that pointage that you get is that you could go buy titanium sheets outside Houston and you get points. You know, there's something that just doesn't jive there. And but I think Leeds is improving as they go on. Okay, earth. Earth has been a building material throughout the world ever since we moved from the caves to create our own shelter. This is a site in Peru, which is right outside Lima. It's surrounded by urban development, but it's 3,000 years old, and it's still there. Of course, it's very dry in parts of Peru, but it goes to show you what our ancestors would do. Okay, the rammed earth has been around for a long time. We're sort of discovering it now, but it's been around for a long time. And this is a 17th century document that talks about other construction methods, but this particular section is on rammed earth. And there's a lot of ancient rammed earth buildings. And here you see different types of rammed earth. So it's been around for a long time. This is our primitive formwork. This is the way rammed earth used to be built, with that kind of formwork. And when it need be, we can always go back to that. It's very simple, very primitive, and very effective. Okay, one of the beautiful aesthetic qualities of massive wall buildings is what you can do. You can actually build spaces there. This is an example of 16th century convent in the state of Oaxaca, in Mexico. And you can see you create a splay, we call them derrames in Spanish, and that's for a given opening you can allow more sunlight. And these were, among other things, reading cubicles for the friars. And sometimes you'll see images of ox-drawn carts on top of the big, massive wall as part of the building process. So there's these inherent structural qualities besides solid thermal and sound attenuation and all these qualities that we have from massive walls. This is a pre-Hispanic horno. There's many types of hornos, ovens. This is in the site of CACTUS, incredible archaeological site. Then you have historic examples of earthen construction. This is in northern Mexico, just it would be west of Monterrey, and it's an Adobe building. And one of the things that I wanted to show you today is how you use other materials to complement your earthen construction. In this case, it's stone. And if you notice, on top of that wall, at one point they brought in brick because they must have been having a moisture problem. So they raised it, and if you look closely at that wall, it's inclined. So it's up and drained that way. And they can get creative too. That's a stone cornice in the shape of a drum. If anybody's been to Guerrero Viejo, that's an incredible, probably the best stone architecture in northeastern Mexico. And it's just down the river from Nuevo Laredo. And it's just a symphony of stonework. And it's really close by to us here. Okay, this is a built-in downspout for an Adobe building. See, our ancestors maybe they weren't architects or engineers, but they had common sense about how to build and how to take advantage of how to work with the environment with the materials that we have at hand. So that's a RAINSPOUT right there, integrated into the wall. The Senoras adoberas. The nice thing about Adobe is it is a very noble building material. Anybody can do it, and everybody does it, the whole community. And we've gotten away from these methods because they're labor intensive. But in communities, the term in English is sort of like barn raising. Everybody helps everybody else build the house, and it goes out pretty fast. And if we can just, right now, this type of construction is only for the wealthy because it's very expensive, the labor is very expensive. But if you have communities that want to participate, you can build your structures. And it goes pretty fast, and the only requirement to whoever the house is being built for is to wine and dine the crew.
The wine and dine.
Okay, here we have a tapialero, a tamper, in a very primitive way of making rammed earth. This is the way it's done historically. And this is down in South America in the Andes. And look how simple. Remember those drawings of the formwork? It's the same thing, it hasn't changed. And luckily for us, there is still, you can go around the world and see all these examples. They're still alive. Okay, this is an Adobe wall in central Mexico, and let me see if this works. No. Did it work?
Yeah. Right below it now.
Oh, okay. Look at the top of the wall and look at the bottom of the wall. Okay, there's a saying, and it probably translates to all the languages in the world. Para una buena casa, hay que tener buenos zapatos y un buen sombrero. For a good house, you need to have good shoes and a good hat. This is unstabilized Adobe, and that wall is probably 300 years old. Unstabilized Adobe. Okay, natural planet Earth. There's a living material that we have in Latin America, that we have it here too. Borders, rigid borders. And it's called Siyat. And I believe with Ed, when he was showing me this building, that part of this building is made out of Siyat. And Siyat is a natural land earth process that you carve it out and make blocks of it. And I was going to build a Siyat house. A friend of mine, a restorer in Mexico, gave me a whole building of Siyat to bring it up here, but it was just, the transportation is so expensive. And that defeats the purpose of working with the materials. You have to, every region has this materials, and just look at the historic buildings. And that's what our ancestors did. But Siyat is a wonderful material.
Is that the same as cup of coffee?
Yes. The Tepetata is the word they use, it's an hour word. You use that more in settlements. And the Siyat is what Tepetata is simply makes you look different because they're smaller, maybe harder. This is particular to the areas around the area. But it's a great building material. And you know what? I'm pretty sure that somewhere around here in San Antonio, there's a good source.
We'll have to find it, yeah.
Yeah, it would be great. Okay, one of the, Spanish America, we always think that the Spanish brought everything. Well, this is a rajueleado, which is a mouthful, is a technique that loosely translated into English is chinking. And that's a way to reinforce your mortar, your line mortar. And sometimes when you're working with the earth, it becomes very thick. So this is a way of protecting that mortar. But it has now become an architectural aesthetic. And people love to get creative with their materials. Okay, sometimes people say that there's limitations to the use of earth or Adobe, but you can build large churches with Adobe if you want to. Hassan Fatih and one of her students, one of his students, Simon Swan, maybe some of you know Simon Swan. He revived this ancient Egyptian technique of creating walls in areas where you don't have access to structural measures. So how do you create shelter without structure? And human ingenuity is just superb. And I'll show you some examples of these type of walls. Okay, here's another example of rajueleado. This is using pieces of brick. But sometimes you see clay, you see glass, whatever you want. Okay, this is a project in Spicewood, Texas, where we made our own buildings. These are sun-dried buildings. And here they are, catching some rays. getting the sun in, and getting the render you use. Okay, this is a project that the photographs are a little light, but it's a rammed earth, and here the material that we're using is decomposed granite. So the two materials that work really well in this area, and Central Texas is just blessed, really good building materials that really go on to your roof. So we have caliche, we have granite over here at the Llano area, granite falls, all that. And those work real well as granite material. You'll see that jam and that arch, that's Texas granite. And then that pattern, that basket weave pattern, those are wood-fired bricks. So it's all very low impact building material, and they just make excellent building materials. Okay, that's what this space looks inside. Originally it was just supposed to be a barn, and now it's a two-family residence. And one thing about rammed earth is the thick walls, and the advantage that you get from it is structural, but also thermal, as you know. So, and it takes a while. It takes 3 men, 40 hours to build a 10-foot long wall, 10 feet. And you compare that to your stud construction, well, there's no comparison. But and this is always an uphill battle to convince clients why they want to build these. Oh, well, how many square feet can I get for this now? You know, well, you should, and if you want to put numbers to it and convince the client that way, say, okay, well, how long is that building going to last? These rammed earth structures, when you finish them, they look like they're 200 years old, and you come back in 200 years, and it'll be right there. Which you can't say for a sheetrock yet. Plus, it's not going to burn down. It has all, as you know, all these thermal qualities. Protects you from drive-by shooting. Okay, here we have a view of the walls. Those are decomposed granite and granite.
That's beautiful.
Okay, and that's just, that material is 20 miles from the site. And really the cost of it is more how much we're going to charge you to get it there. That's what the real cost is. Okay, here we are building a gable. It's not just straight walls, you can build gables and get pretty creative with it. Okay, here, the neat thing about rammed earth is you can, when you finish the wall, that's your finished wall. You don't have to do anything. And it's also very transparent. Not that you can see through it, but you can see how it was built. You know, the steps. You know, you start with the corners, then you build the wall, then the other wall, and then you put the lintel, and then you build the top. So on and so forth. It's like building with blocks, although you create the blocks in the forms.
Oh my God.
You know, those lintels, they're not lightweight. You need a crane to install them. But that's all material within just a few miles from the site. Okay, this is the studio of a friend of mine. He's an artist in Boston. A few of you all went to school at UT, School of Architecture. He was the head of the computer lab. Renaissance man. He played the clarinet. Just incredible guy. And we built this. This is the garage, the carport in West 17th Street. That's right downtown, 2 blocks from the campus. And we had to go to the Board of Adjustment to let us. You could only build in the footprint of existing building. So, and we went over it a little bit, and we presented it to the Board of Adjustment, and they saw the plans, and they unanimously approved it, if and when you build it the way you say you can. So the challenge is to get city council, building inspection department to understand these things. The nice thing about Ryan Griffith is that the building inspectors don't know anything about it. So, okay, here in Bob's studio, we're working with stone. So it's earth, and what else? Limestone. This is part of the richness, the Central Texas land. We go to a quarry in Florence, Texas, not too far from Austin, and they have what they call a bone pile. It's all this discarded stone. You buy it by the ton, $25 a ton. And some good stone workers, they just do magic with that stuff. Okay, here we have a modern pneumatic tamper that we use. It does go faster, but one thing that I've noticed, you notice on that drawing, that 17th century drawing of tamping, their tampers were pointed. And which, maybe there's a lesson there that you can really get into the nooks and crannies in the formwork. So maybe we can come up with a set of modern tampers just for random. Niches. And the advantage of thick wall buildings like this is that you have all this thickness to play with. And you create a niche, and then the resident puts whatever they want to put. And they can get. By the way, that's not a dinosaur bone. It's just a, okay, another here we have a sample of the materials that we used in this building. Grand earth, the material is Ecobos granite. Then we have a rubble fill that we gave this finish made with cactus juice, nopal, baba de nopal, which is a pre-Columbian technique that has been revived, and it's just totally high-end finish. And it has a gleam to it. Then you have the limestone walls, and if you see in the upper left-hand corner, that's the recycled lumber of the carpet that was there. So, very low impact building. Okay, this is one of my favorites. This is inspired in our early settlers' forms of buildings. It's a ranch house in Knickerbocker, Texas, which is about 30 miles south of San Angelo. And there we used local caliche. And actually we were getting kind of picky about our caliche, and we found a little bit better caliche in the ranch next door, so that's where we got it. And then at one point, the owners were a little bit worried that all that weight was going to come crumbling down or something. So they wanted a system of terracing, and we just built this season, this year. And this is all stone right there on the ranch. And it looks like you're in Machu Picchu or something.
Yeah.
Okay, this is an interior shop. The gable roof, it's a volume of a 2-story volume with a gable roof, and then 2 shed roofs on either side of the length, which is pretty much how our ancestors would build, and they were limited in the span to the trees that they could find. This cedar comes from the Bastrop area. Wampers, if you ever go there, they're good suppliers of cedar, and they'll just do anything we need. And And so these trusses are being supported by rendered walls, rendered walls. Now, the wall to the right is a shear wall, and normally you don't do rendered walls in the interior because it takes up so much space and so much time. But just to keep a balance, structural balance, we opted to build these both of the walls out of rendered. But our other material was compressed block. So you have rammed earth and compressed block, all from the site. Another interior shot. Niches. Very different niches. Here is a candle and antique photograph. That's compressed block. We used one of the machines that AECT fabricates. Okay, this is a house in Alpine, Texas. It's an Adobe house. You can probably see it when you're coming in from Fort Stockton. It's on the other side of the Senoras campus. And then we use stone for the windows, all the way, ox-hides, quadrifoil windows, Adobe walls, and then I call them Nubian vaults, bovis. And it's just, if you've ever seen one built, it's just magic to see how you can build your shelter without using formwork. That's what it looks at the end.
Yeah, they have that at the Mission Library now. Did you know that? Next to Mission San Jose, they built those vaults.
Oh, yeah?
Oh, yeah. Mission Library.
The first person I know that dropped us here was O'Neill Ford, and he built it for Steve's house, and then he built the bedroom for his sons. And what was really ironic is that the guy that built these was the son of the one that O'Neill Ford.
Wow.
And now I'm working ranch. So it's a technique that is passed on through families. And I have really good masons that have tractors.
Yeah, that's nice.
It's not easy. Patterns. You can get all sorts of patterns with the brick wall.
Logan, how is that waterproof, that previous slide on the outside? It's
Oh, well, first you put like a stucco mortar over it, then you put a waterproofing agent, and then you put the tile.
Oh, okay, so that was another layer of tile. Okay, gotcha.
Okay, another thing is the built-in furniture that you can do with thick walls. And these are cabinets that we built through the wall. This is the technique, by the way, that was imported to the New World when Spain had this trade with Asia, from Acapulco to the Philippines. And this is an Asian technique that was brought over to the New World, and now it's only one very remote village that still does this technique. And the place is called Rinalá, in the city of Guerrero. Okay, there's limitations to this vaulting system. Those are rammed earth walls. This is a project in Tucson, and working with the PE, the bovedero, the architect, and the engineer, the span was too large, but we came up with a solution, and that was to create these steel arches, and the span is in between the steel arches. And that way we were able to get this huge span for this space. And that's what it looks like now. How they got those two dogs to stay still for the photo? Almost look like statues. Okay, this is a house in Austin, the Hood House. It's a two-story rammed earth structure. And they really got into it. And this house got the maximum Austin Energy Award ever They have a wetland system, rammed earth everywhere, solar panels, just you name it. This is an interior shot. Notice that we built a cement arch there to go into the living room. This is going up to the second story, and that's what you greeted with. A bóveda with different types of brick. Okay. Working with students at Texas A&M, I had a course where it was getting the students to build things. But the requirement was that it either had to be a natural material or it had to be a recyclable material. And they came up with some beautiful examples. And the first thing was to build these samples of rammed earth and to test them. This is a column with a little sculpture, stone sculpture. This is a rammed earth floor. This is a little structure you were talking about, the garage hall. This is sort of like a garage hall. This is compressed soil block, cedar trusses, and cactus stucco. Earth stucco and then cactus stucco. This is a sample of a rammed earth wall that one of the students, her last name is Altenhof, and that's why I'm calling it the Altenhof wall. And there she's using caliche and decomposed granite. Okay, these are two columns that these two students really got into it and built these columns. One is decomposed granite, the other one is caliche. And this is in the Riverside campus. It's not the main campus at A&M, but it's one thing that UT doesn't have is a place to build stuff and let you do experimenting. But anyway, at one point the university said, well, we got to knock all these little structures we have here. We call them shrines. They're a hazard. And they knocked everything down, even the little house that we built, but they didn't knock down the columns. For some reason they never. Okay, Quinta Carolina. This is a project where we actually made the adobes at the site. We harvested the cactus. We harvested the limestone. And we built some boulders. That's what that make space looks like. And it was challenging for the vault maker because it was all this irregular form shapes of the walls and the spaces. And outside corners work well for bóvedas, but inside corners don't. And but he was a very good bóveda. This is a window. This is one stone that was carved. Oh. Okay, this is a 16th century mural by indigenous artists, and they're celebrating the Opuntia cactus. That's the prickly pear cactus. And the prickly pear cactus in the highland of Mexico is the world tree. Its roots go into the underworld, they're on the ground, and then they go to the sky, to the heavens. And that way those three realms are connected. In the Maya area, it's the ceiba tree. And if you go to the jungles of Guatemala and Mexico and Belize, it's all full of trees, it's a jungle, but the ceiba stands out. And this is in highland Mexico. The world tree is a cactus. Nopal, we call it. This is what it looks like. Baba de nopal. If you translate that, it means cactus druids. Doesn't sound very appealing, but it's a binding material, excellent binding material. And then you can burnish it, and that's how you get that sheen from it. It's labor intensive, but see, that's a convent in Oaxaca with the cactus. And this technique was revived to restore the main Dominican convent in Oaxaca, and now it's catching on. Another thing that we did in this project was radiant slab heating and cooling. And it wasn't liquid, it was connected to the AC system. So you have heating and cooling in the floor, which is the best way to heat a building. You don't hear anything, you can go around barefooted in the harshest winter. It's great. This is what the floor looks like. All that limestone, we harvested and carved it, hand carved it with primitive tools, 20 feet from where it was being used. And it was all these curved walls, but here you can see, okay, you have adobe walls, you have the cactus finish, you have mesquite doors, and you have the bogas. Mesquite is a wood, excellent building wood. And we have plenty of it here, and the government pays you to destroy it, get rid of it, or use it for barbecue. But it's an excellent building, and those doors are antique doors, and they're made out of mesquite, and they're very weather resistant. Why can't we make that? These were the downspouts that were carved right there at the site.
I love
That's in place. The client was in love with their dogs, so we made sculptures of the dogs. That's what the cantero, that's the stonemason carving, the primitive tools. And this is the closet of this lady's space. That's what you look up and that's what you see. And now, let me see if I can get this to go. Well, that's it. Thank you.
Bravo.
So, if there's any questions?
One, Logan, you were mentioning that cactus juice finish on that. It reminds me of the Cadillac finish that was famous in Morocco. Is there a similarity between that kind of finishes, or how's it?
What did you call it?
Cadillac?
Cadillac?
T-A-D-E-L-E-K-T is the like English spelling for it.
Is it from Cactus? Do you know?
I don't think so.
No, it's so,
Lime.
Because this is the, and we have to go and harvest cactus to get it. And you cut it up in little pieces, and you put it in a bucket, and put a little water on it, come back the next day, and you have all this
We used this
burnishing
here
liquid.
in one of your demonstrations about 6 years ago. As for the cactus was putting in a plaster because the plaster didn't crack with it that way. I think Jim was, he had a partner and they held it at ECT.
Yeah, we used cactus juice in ECT workshops there.
They didn't burnish it, but they used it to hold the plaster together with the cracks.
Mhm. It's a binding element, excellent binding element, and you can mix it with your paint. It's going to last a long time. Cactus is a very, very useful plant, and here we destroy it, we don't use it. In Mexico, there's whole plantations of it, and not just for nopalitos and eggs. For a bunch of different.
And that plaster that was burnished there with the cactus, what did you mix with the cactus juice?
It's a mortar that we make with lime mortar and clay. The clay actually gives it the color. And the prickly pear cactus juice. And after you mix it and you trowel it on, then, and it's millimetric, the thickness of it. It's the finished coat. And then you can start burnish it with smooth river stones, things like that, maybe even a plastic bag. It's time consuming, but then you get this really high-end finish to it. And it was used in temples, Maya temples. And then the friars in the 16th century picked up on it and used it for the altars, the most sacred space in the church, the altar. Right there, the walls, and they used it as a fresco material as well.
Does it lose its sheen over time?
Pardon?
Does it lose the sheen over time?
If you use it as an exterior, you will lose the sheen, but it's still a very good exterior material as well. We did a project in Austin where the whole exterior is in cactus stucco. So, yeah, you'll lose a sheen if it's exposed to the weather, but in the interior it doesn't. So, it's all these natural materials that we have forgotten how to use in the building industry. You know, and we cause so much impact that maybe we should start looking back into it.
Do you use the same masons for all these different projects?
Yes,
So
I
they,
do,
yeah,
and not only that, they do the whole project.
they do the whole project.
They do the whole project from the steel of the foundation, and people come up to me and say, wow, where did you get these steel guys? They're really good at foundations and the steel and tying it and pouring the slab and building the walls and finishing them and doing the domes and tile. And it's just all natural materials.
Mhm.
So if you could calculate the embodied energy, it's as low as you're gonna get and still have a beautiful building.
So Logan, do you think there are many of those kind of people in Mexico still with those kind of skills?
It's a species in the verge of extinction, even in Mexico.
It's
You have to go
scary.
to really remote areas to find them. That's where I thank my background in anthropology, that you go to these areas, and it's interesting because they have to build, just like our ancestors, they have to build with what's there. And they develop it into an art form. And they're very good builders. We don't build them like that anymore. We have to find a way that we can make it so it's economical for everybody, not just for very wealthy people. But the only solution that I see is doing community work, you know, because it's labor intensive.
Can I ask you a personal question? Obviously you have this deep knowledge of all these different traditional ways. Were you interested in this as an architecture student? And how did you get involved in earthen construction?
In my background in anthropology
Yeah,
and
also,
archaeology.
yeah, okay.
That's how I
Oh.
started out.
Oh, okay,
That's the first thing I studied.
okay.
And then you have to go through your undergraduate, which
Right,
the
right.
normal courses, but
Right.
then in graduate school, I wanted to get back to that, and so I majored in historic preservation
I see,
and worked on a lot of preservation projects.
okay.
But at one point, you decide, well, the corpus of historic buildings is limited.
All right,
If we like these buildings so much, why don't we continue doing it?
yeah, in the traditional way.
In the traditional way, but that doesn't mean that you're limited to
Right,
a
tradition.
certain style.
Right, yeah, you can do anything, right.
You can do anything you want.
Right.
Be as modern as you want,
Awesome.
like all these curved walls.
So how long ago was it that you made that transition to actually being a builder?
It's an evolutionary process.
Okay,
And maybe I can thank my parents that would take me to archaeological sites
okay.
where in Mexico they're all over the place.
Yeah, right,
And you get a certain feeling from going to them
right.
that you don't get just walking down the street.
Right.
And,
Do any of your stonemasons still speak indigenous languages?
oh yeah, Zapotec and Navajo. Yeah.
That's
Did,
remarkable.
did you carry out some of your studies in Mexico?
Pardon?
Were some of your studies done in Mexico?
Yeah, I grew up in,
Oh, I didn't know.
and I became an
Come over
architect in
here and
Mexico. I
then
studied
studied
anthropology
what?
in Mexico. I just came here to graduate school. I
Oh.
was born here in the States. So I came to graduate school here, and then at one point I had already graduated, and the dean asked me to help him do research in Mexico, and that's how that book on plazas came
Yeah,
about.
yes, beautiful.
And that, all that research helped me find these craftsmen.
So,
They're
yeah,
still
you-
out there, but it's a species that is about to get extinguished, even in Mexico, even in
Wow.
Peru, countries like that. And,
Do you speak some
and
of
there's
the
countries
languages?
that, pardon?
Do you speak some of the indigenous languages also?
Oh, a few words. But, third world countries or developing countries, they're faced with the dilemma how to create low-income housing.
Right,
In some countries, especially in Africa, they realized the only way that they can provide dignified shelter is to go back to the vernacular methods.
So when it comes to like, and it being affordable for, say, someone using it for low income housing, when you talk about it withstanding elements like in the foundation and the building of it, how often, or maybe like is it necessary for repairs, or are you sure there are gonna be people around, or are you aware to do repairs on?
Well,
The
that's where,
construction.
we had a program at A&M down in the valley. The colonials, these are immigrants that come, they're just getting there and they won't have a place. And we would teach them how to build like this. They could do it. You saw the adoberas, they're not, I mean, they know how to work Adobe, but anybody can work Adobe. And yeah, you need the engineering to make sure that these are heavy buildings. So you want to have a good foundation, and that's expensive. But there's some primitive methods to do foundations as well. But that's where I take my hat off to good engineering. To make sure that your building doesn't fall.
Building the foundation is less expensive than having sweat equity of the family building themselves above that, right? So if they're making the abilities, or they've learned how to do it, or there's a
Yeah.
cooperative that's making them?
Yeah, a cooperative is a good way. And still in communities, indigenous, especially indigenous communities throughout the world, that's how they build. The whole community says, you need a house, okay, we'll build it. Just wine and dine us while we do it. And that's the exchange. We've lost it.
We have the Portugal as potential helpers and not making use of them. I don't see why I can't put the immigrants that are coming over and want work to work.
Yeah, they can teach us a lot of lessons.
And they
How
could
to build
prosper
like
and we could prosper.
Pardon?
We could all prosper from that, benefit from it. If we employed them and gave them a chance and they appreciated the work.
Yeah. And the problem with how conventional construction occurs here, sheet rock and studs, which is not a very good building.
But it
And the
doesn't
rest of
last.
the world is just appalled. How can most developed country in the world be building like that? And it's all about how fast can you build.
Fast and money, but it doesn't last a generation
It
or two.
doesn't, it doesn't. Ask a contractor here that builds conventionally, how long is he gonna guarantee those walls? You're lucky if you get 7 years.
I was
And-
hoping
and-
30.
And when they ask us, okay, well, how many centuries do you want it to last?
Huh.
I describe American construction, 3 terms: fast, cheap, and temporary.
And temporary, we live in the temporary culture, it's throwaway buildings.
I wanted to address a little bit what you said about, that it's been lately at least more of a high-end product, because we have to talk to people into spending this extra money on the walls. But just in the last year and a half, due to some governmental policies, the Canadians decided to strike back. Lumber, is nearly doubled due to the tariff situation. And we priced out a 3-bedroom, 1.5 bath house model that we built last year in Colorado. A 3-bedroom, 1.5 bath, 900 square feet, I think it was, with the earth blocks, and then we had a regular contractor place that, and we were actually cheaper.
Yeah, I'm finding that rammed earth, yeah, it's a little more expensive, and it's a lot more built that you get.
But you have, if you're making your own blocks and stacking your own blocks and plastering your own blocks, you have one crew and the wall is finished. On a stick wall, you have 7
Yeah,
trades.
that's another fallacy
You
about
have
how we build it.
7 trades that are taking the profit. you know?
Right, they're taking a profit, and then if something goes wrong, they start pointing fingers. They blame each other. It's nothing like having a crew that does it from the beginning to the end.
Do you recall how long it took to build Casa Carolina?
A long time. A long time, and a lot of it had to do with the work permits. The government gives me 9 months. 9 months, and that's what, so the client has to be patient. They get buildings like this, and they are patient, but it takes a particular client that really wants it. Because if it's, oh, well, I want it next week, it's not gonna happen. Now, you can have larger crews, and I've experimented with that, and it does go faster, but there's a limit to that, because if you have too many people, you start tripping them on each other.
Okay, we have time for just one more question, and we have to sign up.
Yes, actually, and if we wouldn't mind, maybe we could all gather and take a photograph today?
Sure. In the room?
I don't know if do you
It's
guys
getting
think
dark
there's enough
outside.
light outside? No? Okay, yeah, I guess in the room now. Does anybody have that last question for Logan?
I just say, when it comes to, because the idea of ours is behind affordable housing. So when you're looking into affordable housing and creating affordable housing for people who are already here, as far as it being, we have to take into consideration also anything that would come along with it as far as repairs and costs into, you know.
Building with
foundation
earth
and
is a very noble way of doing
everything.
it. It's easy. It's not that difficult. And it's easy to repair. One of the projects that was built in 2000, they just called me back and we did some repair work. There are skills that are being lost, unfortunately, but this is a way of reviving those skills. One time I was asked to, well, where are you going to get adoberas? And we put an ad here in San Antonio. Buscamos gente que sepa construir con adobe. It was inundated with responses. So the craftsmen are out there.
Looking for something to do.
Looking for something to do, but they bring these skills that don't exist. And there are also skills that can be taught. I mean, those old ladies were building that Adobe. And the thing about Adobe is that you have to make it a certain size that you can be carrying it all day long. So it can't get too big.
Thank you so much.